Most mixers contain what we call a valve stack to control the hydraulic up and down of the bowl. This here is our standard valve stack. It's 24 volts control voltage. You can see that on the top. It'll tell you what the control voltage is and max pressure is. The valve stack consists of multiple levels. You have a 24 volt control circuit on top with override locks and coils for either direction, flow controls for either direction, balancer valves for either direction as well, with a pump override for manually operating the system. The very bottom has your standard tank and pressure ports, which connect to your hydraulics themselves. So going through the coils themselves, self-explanatory. If they fail, we can replace just the upper unit or the card or the coils themselves. If needed, the override can be initiated and locked, which allows the pump to activate, and you can manually pump the system down, up or down. That's how you manually lock and override and then use the pump to move the bowl. The flow controls themselves control the speed of open and close. We set them for 15 seconds to open and to close. If adjusted at all, the bowl limit switches must be readjusted as well to minimize damage to your machine. The balancer valves are designed and developed to minimize acceleration as a bowl would open or close because of the differential in weight when a full bowl is opening versus an empty bowl is opening. So it basically requires a specific pressure to be met prior to movement so that it has a smooth, consistent movement. The override, it's just a simple pump system. It's how when you lock the valves, you're able to do it. Get the bowl to move. The system is based on a normally open system, so the flow is completely available at this point. There's nothing holding the oil in position, so when you lock, that's what allows it to function. Your port's pressure will go to your cylinder, tank will go to your tank. You will also have an analog gauge that will show you the pressure the system is using at that point in time to move the bowl or to go into override. This is your basic valve stack system in most CMC mixers.
My name is Ed Fay, and Joel Swidergall just did a brief introduction of the components involved in the hydraulic system. I'd like to go through some of the basics of their operation now. First of all, we have the pump, hydraulic hose sets, the valve stack, and the cylinder. They're generally oriented like this in each and every one of our mixers. This is the 24 volt valve stack. We also have 110 volts. One thing that's important to know is that these were all set and calibrated here at CMC America during setup of the mixer. For practical application, if there was a power outage in the bakery, you need to have some way to open the bowl lest yeast raised dough build up pressure overnight or some extended period of time inside the bowl. So OSHA requires mixers to have an auxiliary opening and closing method in the event of a power outage. So in all of our mixers, we have a valve stack that also includes an auxiliary manual pump. How does this operate? First of all, the actual electric solenoid that makes the mixer bowl and the hydraulics go up or down, this is the solenoid. It's a 24 volt coil. The solenoid is both up and down and usually well marked so you can see which end is which. In a manual intervention, these golden locks are manual. You push them and turn them and they will hold in. This, when we take the lever, introduce it into the pump, we can move the bowl slowly and pump up and down, at least to crack the bowl open and allow pressure to be relieved on a yeast raised dough. If you're not working with yeast raised doughs, that's not as important, but we have to be ready in the event. So we always have a handle, and we always have the hydraulic valve stack. We set the pressure here at our plant for between 9 and 1200 psi. This pump can generate up to 3000 psi. So the actual settings on the pressure and the speed, which are these settings here, are done at CMC America. We encourage people not to mess with these settings. But remember that we always have this system set up for about 900 psi. Maybe as high as 1200, depending on the dough that we're working with. And that can be adjusted, but it's not something to be trifled with. The reason I say that is that if you change the speed settings for the bowl up and down and speed it up, then you must absolutely affect change on the limit switches to stop the bowl in the correct position. In the event you change the speeds and you do not reset the limit switches both up and down, you can run the bowl hard closed and then hard down each and every time. That can actually break components because the amount of pressure that the hydraulics can generate is well beyond what a lot of metal can stand up to over repeated hard opens and hard closes. So in the event anyone changes the speed of the ascent or the descent of the bowl for dumping out of dough or for closure after emptying the bowl, you must affect change here because hydraulic systems have what's called drift. And after the pressure relieves, it still drifts slightly. And if you don't accommodate the drift because you change the speed up or down, you can cause trouble. Other than that, what Joel went through was pretty clear, but this is a detail that needs to be reinforced. These limit switches are set with Allen head set screw here. You can adjust the position, and then when in full up or in full down, the bowl will stop its movement either direction. But it's a very simple change and can be accommodated easily, but it's a step that many people overlook. So we wanted to reinforce that today. It's inherent in every one of our mixers. And so there's the component setup, which Joel went through quite clearly. The systems settings are also critical and should be part of this teaching moment. If there are any questions on any of this, please call CMC America at 815-726-4337. Our people are available and glad to help. Thanks.